Hey guys, happy Thursday. Hope you all are doing well and that you remembered to bring your earphones today so that you could get the lesson. So please make sure you have your notes open, ready to go, and that you're taking notes during the video and then working on the assignment afterwards. So today we're going to look at finding the trigonometric functions of any angle, which is something we worked on a little bit last year, finding cosine, sine, and tangent of any angle on the unit circle using our special right triangles. So you're going to want to have out your special right triangles if you don't know or have the side lengths memorized yet. And you really need to work on getting those memorized. So knowing that, across from the 30 is square is 1/2. Across from the 60-degree angle is the square root of 3 over 2. Across from 45 is square root of 2 over 2. So you need to kind of just have those memorized and know them because we're going to be using those numbers all day and in this entire quarter worth of chapters. Okay? So we're going to go ahead and get started. And the first thing we're going to talk about is finding the sine, cosine, and tangent of any angle. Again, this is really just to remind you guys that any angle on the unit circle has a set of coordinate points. And the coordinates of any point on the unit circle are cosine of theta as the x value, sine of theta is the y value, and then the tangent of theta is opposite over hypotenuse. And since sine represents the side that's opposite and cosine represents the side that's adjacent, tangents is really just sine over cosine. Okay? And then, of course, you know that cosecant, secant, and cotangent are just the reciprocal functions. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Okay? So here's our first example. It says, let P, the point -2, -5, be a point on the terminal side of angle theta drawn in standard position. So first thing I'm going to do is just draw my coordinate plane. And then on that coordinate plane, the point -2, -5 is maybe somewhere around here. So what I'm going to do is I'm going to draw my angle in standard position to that point. Okay? Now, hopefully you remember this from last year, but when we draw our reference triangles, we always connect to the x-axis. Okay? Always back to the x-axis. And then we can label this triangle with the lengths depending on, where that point is. So since we went left 2, this side length will be -2. Since we went down 5, this side length will be -5. So what we need to first do is find the hypotenuse using Pythagorean theorem. So 2 squared plus 5 squared equals c squared. 4 plus 25 is c squared. Oops, c squared. So 29 is c squared, making c the square root of 29. Okay, so I'm going to label that on my triangle. And then what that's going to allow me to do now is actually go ahead and find all 6 trig functions. So sine of theta is, and this is theta, the opposite, -5 over hypotenuse, square root of 29, which you can go ahead and rationalize if you want. I'm not going to. Cosine of theta is adjacent, -2 over hypotenuse, square root of 29. Tangent of theta is opposite, -5 over hypotenuse, -2, which will change that to positive. Cosecant is the reciprocal of sine, so square root of 29 over -5. And it really doesn't matter where the negative goes as long as there is a negative. Secant of theta is the reciprocal of cosine, so square root of 29 over -2. And cotangent of theta is the reciprocal of tangent, so 2 fifths. Okay? So there we have all 6 trig functions. Okay? Hopefully that was pretty self-explanatory, so I'm not going to do the second skill practice if you feel like you need to practice that one, go ahead and do that one, on your own. And then you can check the answers with what's in your book because the skill practice answers should be listed there. Okay? So here they're talking about drawing a reference angle, and this is the same thing I was just talking about, where when we look for any angle on the unit circle, we just connect it back to the x-axis. And then the angle that we're actually working with is this theta prime, the reference angle, which is the difference between the angle they're asking us about and the x-axis, which is either 0 degrees or 180 degrees, depending on if you're on the right side or the left side. So your reference angle is really just how far away from 180 or 0 you are. Okay, so just the important part is remembering always connect back to the x-axis. So here's our first example. It says find the reference angle theta prime. So for a 315-degree angle, I'm just going to make a little sketch here. 315 degrees falls past 270, right? And before 360, so right in here. Okay. Again, that reference angle is that angle such that when I connect it back to the x-axis, this is theta prime, the angle that's in that right triangle. So if this is 315 and this is 360, the reference angle is the difference between 360 and 315, which if you subtract that, you get 45 degrees. So our reference angle is 45. Okay? For negative 195, we go clockwise because it's negative. So negative 90, negative 180, negative 270. So we're just past negative 180. Okay? And then our reference angle again is what happens when we connect back to the x-axis. Well, it's the difference between 195 and 180, which is 15 degrees. Okay? 3.5 doesn't have a degree symbol after it, so that means that this measurement is in radians. So I'm not really going to focus too hard on this just because it's kind of weird. But if you know that pi is 3.14, 3.5 is just past that, or 3.5 I mean, is just past that. So our reference angle theta is the difference between 3.5 and pi. So I'm just going to write theta prime equals 3.5 minus pi, because pi is irrational. So that's basically all you need to do for C. And then D is an actual radian measurement, 25 pi over 4. So first thing I want to do for that is just figure out where that is. And what you should remember is that pi over 4 is 45 degrees. So if we have 1 pi over 4 is 45 degrees, and I multiply that by 25, 45 degrees times 25 times around the unit circle is 1125 degrees. So the other way you could look at it is, if you know pi over 4 is 45 degrees, that means every 45 degrees is 1 pi over 4. So here would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 pi over 4. So this angle right here is our reference angle, and that is just pi over 4, which is 45 degrees. Okay? So, I'm just going to pick a couple of these to try. I'm going to do just A and D here. Reference angle for 150, 150 is before 180, so here. When I drop it to the x-axis, the reference angle is the difference between 150 and 180, which is 30 degrees. Okay. 13 pi over 3. Well, you should know that pi over 3 is 60 degrees. So every 60 degrees is 1 pi over 3. So if I do pi over 3 times 60 degrees, I'm sorry, not pi over 3, 13, because there's 13 pi's over 3. 13 times 60, that gives me a total of 780 degrees. So I'm going to figure out where that lands on the unit circle by finding its coterminal angle. So subtracting 360, and that'll give me 420. So I'm going to subtract another 360, which will take me to 60 degrees. Okay. So that means that 60 degrees is my reference angle. But since the original problem was given to me in radians, I'm going to convert that back to radians. So you should know that 60 degrees is pi over 3. So your reference angle is pi over 3. Okay? So I'm just going to take a quick second to sidetrack here because I've said it a few times now in this lesson, and that is you should know that this is this. So I just want to clarify what those things are that you should know. You should know the basic first quadrant radian to degree conversions. So for example, you should know that pi is 180, which would mean that pi over 2 is 90, pi over 4 is 45, pi over 3 is 60, and pi over 6 is 30. Those are the 5 that you absolutely really should know. And I suppose you should know that 2 pi is 360 also. Okay, so that it'll make your conversion process just so much easier. If you know those and you have those memorized, you can convert back and forth between degrees and radians really quickly and really easily without having to set up that proportion every time. Okay, so I'm just going to continue on with the lesson here. This table just kind of gets at exactly what I told you. You should know that these, what these conversions are here. And then we already kind of went through all this when we created our unit circle with the sine, cosine, and tangent of all of the angles on the unit circle. And then just remember again that your reciprocal functions are just exactly what those are, the reciprocals of the 3 basic trig functions. So cosecant and sine, cosine and secant, and tangent and cotangent go together. Okay? So here's where it starts to get real. This is what we have been preparing for, is just being able to find the sine, cosine, tangent, cosecant, secant, or cotangent of any angle on the unit circle. So sine of 240. How am I going to tackle this? Well, I'm going to tell you, you're not going to just plug it in your calculator because your calculator is going to give you a decimal answer. And we know that some of our sines and cosines are things like the square root of 3 over 2 or the square root of 3 over 3. And those are things that you can't just get from putting in the calculator because I want you to leave them in exact form. So how do we do this? Well, first thing you should do is make a sketch of this angle. So where does 240 lie? It lies in the third quadrant past 180 but before 270. Okay? Your next step is going to be drawing your reference triangle. So that means connecting back to the x-axis and figuring out what your reference angle right here, theta, is. So between 180 and 240 is 60 degrees. So you're going to use 60 degrees as your reference angle. That automatically makes the other angle in the triangle 30. And then what we should do is we should label the side lengths. So hypotenuse is always 1. Across from 30 is always 1/2. Across from 60 is square root of 3 over 2. And again, you should have that memorized. And then we have to apply negatives. So since we moved left, that measurement's negative. Since we moved down, that measurement is negative. Okay? So now, when we're taking the sine of 240, we're really taking the sine of the reference angle, which is 60, and they're the same thing. So sine is opposite over hypotenuse. So opposite is negative square root of 3 over 2 over the hypotenuse is 1, which means that the sine of 240 is just the negative square root of 3 over 2. Okay? You'll get really good with this process. So let's try another one. Tangent of negative 225. So step 1, draw the angle. This time we're going the opposite direction because negative 225 is negative. So here's negative 90, negative 180, negative 270. So before negative 270 is negative 225. Okay? Next step, draw our reference triangle. And our reference angle here, theta, is the difference between 225, which is what this angle is, and 180, because we're connecting back to the x-axis. So the difference between 225 and 180 is 45 degrees. Okay? So I'm going to label my side lengths. Across from 45 is square root of 2 over 2. Again, that would make this other angle 45 also, so square root of 2 over 2. Hypotenuse is always 1. Apply my negatives. I moved left, so negative. I moved up, so that one will stay positive. And now I'd take the tangent. So tangent of negative 225 is really tangent of my reference angle, 45, which is opposite square root of 2 over 2 over adjacent, negative square root of 2 over 2, which is just negative 1. Okay? So tangent of negative 225 is negative 1. That one you could check in your calculator because that doesn't have any irrational numbers in it. But then make sure your calculator's in degrees. Okay? All right. I'm going to try another one. 11 pi over 6. Yuck. I don't like working with radians. So what I'm going to do is I'm just going to quickly convert this to degrees. And the easiest way to do that is just to know that 1 pi over 6 is 30 degrees. And so if I have 11 of those, I'm just going to multiply by 11. And 30 times 11 is 330 degrees. Okay, easy enough. So I can now sketch that. 330 falls right about here. Drawing my reference triangle back to the x-axis. Difference between 330 and this would be 360 is 30 degrees. So that's my reference angle. Okay. Labeling the sides then. Hypotenuse is always 1. Across from 30 is 1/2. This would be 60. So across from 60 is square root of 3 over 2. I moved right, so that one's positive. I moved down, so that one's negative. Okay? So the secant of 11 pi over 6 is really just the secant of this 30-degree reference angle. And then you have to remember secant is one of those reciprocal functions. And secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. Okay, so the hypotenuse is 1. The adjacent side is square root of 3 over 2. Gross. Fraction under a fraction. So multiply, keep the first one, multiply by the reciprocal. All right, hold on, my pen froze here. Okay, sorry about that. So we multiply by the reciprocal. 1 times 2 over the square root of 3, which we know is just 2 over the square root of 3, which I'm actually going to rationalize this one because it's pretty simple. Just multiply by the square root of 3 over the square root of 3, and you get 2 root 3 over 3. Okay? So there you have the secant, which is kind of new for us. We didn't do reciprocal functions with this last year. But it's really simple because you just do the the reciprocal of the cosine. Okay? All right, let's try another one. Cosine of 5 pi over 6. So again, first thing I'm going to do is I'm going to just quickly convert this to degrees. So I'm going to do that by knowing that pi over 6 is 30, which if I have 5 of those, I multiply by 5 and I get 150 degrees. So I'm going to go ahead and graph a 150 degree angle, which I know is right here. Okay, I'm going to make my reference triangle, and then my reference angle is going to be whatever the difference is between 150 and 180, which I know is 30, which would make this other angle 60. And then, I don't know why I cramped myself here so far to the left. I have this whole section to use. So I'm going to move over a little bit. I'm going to label my side lengths. So side across from 30 is 1/2. I know hypotenuse is 1. Across from 60 is root 3 over 2. Moved left, so negative. Moved up, so positive. Okay? So the cosine of 5 pi over 6 is the adjacent side, which is the negative square root of 3 over 2, over hypotenuse 1. So I don't need to worry about that. Okay? So negative square root of 3 over 2. Okay? Another one here, cotangent of negative 120 degrees. So I don't have to do any converting here. I'm going to go right to sketching. And negative means I'm going to go the opposite direction. So if this is negative 90, this is still 180, but I guess negative. That means negative 120 falls right about here. Okay? And again, always, you're going to hear me say this about 1,000,000 times, always connect back to the x-axis. Okay? So difference between 120 and 180 gives me a 60-degree reference angle. That makes my other angle 30. Hypotenuse is 1. Across from 30 is 1/2, but since I moved left, it's negative. Across from 60 is square root of 3 over 2, but since that's a downward side length, it's negative. Okay? So the cotangent of negative 120 is the reciprocal of tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So adjacent is negative 1/2. Opposite is negative root 3 over 2. So I've got some simplifying to do. Negative 1/2 times the reciprocal, 2 over the square root of 3, negative. Okay, well, negative over negative times negative will make it positive. The 2's drop out, and I get 1 over root 3. I'm going to rationalize it, so root 3 over root 3 gives me positive square root of 3 over 3. And there I have my angle, cotangent of negative 120. Okay? Next one, cosecant of 7 pi over 4. I'm going to convert that real quick. So if I know that 1 pi over 4 is 45, multiply that by 7. So 45 times 7, I get 315 degrees. Sweet. Okay? So I'm going to sketch. 315 is going to be right about here. Connect back to the x-axis. Difference between 315 and 360 should be 45 degrees. Yep, so that's my reference angle. Hypotenuse is 1. Across from 45 is root 2 over 2, but I moved right, so positive. Across from 45 again, root 2 over 2, but this one's down, so negative. And now cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, then cosecant is hypotenuse 1 over opposite, negative square root of 2 over 2. All right, gross. I'm going to have to fix this. So 1 times the reciprocal, 2 over the square root of 2, negative, is 2 over the negative square root of 2. I'm going to rationalize, and I'll get negative 2 root 2 over 2. Well, the 2's drop out, so I just get the negative square root of 2. Okay? So there are 6 examples of finding the trig functions on the unit circle. Hopefully you remembered some of that. If not, hopefully you understand it. This one is another example now, but this is a unique example because when I look at 9 pi over 2, my first thought is to quickly convert this. So pi over 2 is kind of one of the weird ones. It's the 90-degree angle, which then when I multiply that by 9 of them, I get 810 degrees. So where the heck is that? Well, I'm going to find what it's coterminal with. If I subtract 360, I get 450. So then I'm going to subtract another 360. And I get that this is actually just a 90-degree angle. Okay? Well, 90-degree angle is right here. There is no reference triangle to draw with that. What you just need to know is that the coordinates of an angle on the axes, this is just 0, 1, because the radius is 1 in the unit circle. So the secant is 1 over the cosine, right? And the cosine is the x coordinate of the coordinate of your point, the ordered pair. So 1 over the cosine coordinate, which is 0, is actually undefined, right? The denominator can't be 0. So that's actually just undefined. And that's just how it is. Okay? This is like all the other ones we've done, so I'm just going to skip this one. And then I'm just going to do one more of those weird axis angles. So 11 pi, when I go to convert this, I'm thinking to myself, well, 1 pi is 180. So 11 pi means I'll just take that and I'll multiply it by 11. Now, the interesting thing about that is this is going to be huge, right? It's actually 1,980 degrees. So you can go ahead and just start subtracting 360 a bunch of times to get the coterminal angle. Or you can know that if pi is right here, if we just do that 11 times, it's 11 semicircles, right? Here's 1 pi, 2 pi, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm right back where I started. It's the same as 1 pi, right? Well, what are the coordinates over there? Coordinates over there are negative 1, 0. Well, what is cosecant? Cosecant is 1 over the sine. Okay, well, what is the sine? Sine is the y coordinate, which is 0. 1 over 0 is what again? Undefined. That's simple. Okay? The last couple examples here actually give us some ratios. And what we need to know is where are things like sine and cosine and tangent positive or negative? Well, again, you have to remember that in your ordered pair, the x is the cosine, the y is the sine. So in this example, it says that the sine of theta is negative 4/7. So when your sine is negative, that's your y coordinate, that means you've moved down. So we're in one of the bottom two quadrants. And it's telling us that the cosine is positive. So that means you've moved to the right. So down and to the right puts us in the third quadrant. So when I go to graph this, I'm going to graph an angle right here in the, I'm sorry, that's not the third, that's the fourth quadrant. What am I thinking? 1, 2, 3, 4. Okay. That puts me in the fourth quadrant, which then when I draw my reference triangle, I connect back up. Now, sine is opposite over hypotenuse. So that must mean that that this angle, the opposite of it is -4 because it moved down. So I'm going to put the negative there. The hypotenuse must be 7. Well, to find the cosine and the tangent, I'm going to need that third side. So quickly, I'm going to do my Pythagorean theorem. Right? 7 squared, I'm sorry, equals, that's my c squared, a squared plus 4 squared. Doesn't have to be negative because when you square it, it'll be positive anyway. 49 is a squared plus 16. Subtract your 16. A squared is... A squared is what? Oh my gosh. 49 minus 16 is obviously 33. So what is a? The square root of 33. All right, cool. Now I can find the cosine and the tangent. So cosine is adjacent. So square root of 33 over hypotenuse 7. Tangent is opposite, -4 over the square root of 33, adjacent. Which you could go ahead and rationalize. This one I'm not going to because 33 is weird. This isn't like a unit circle measurement. Okay? So let's do one more of these. Given that the cosine is -3/8, okay, so when your cosine is negative, and that's your x, that means you've moved left. And your sine is less than 0, so negative. So when your y is negative, that means you move down. So we're in, this time we're actually in the third quadrant. Okay, graphing an angle in the third quadrant, connecting it to the x-axis. Cosine is adjacent over hypotenuse, so the adjacent side must be -3, hypotenuse must be 8. Got to get my third side, so 3 squared plus b squared is 8 squared. 9, I'm sorry, plus b squared is 64. B squared is 55. B is the square root of 55, but it's going to have to be negative because we moved down. Okay? So what does that mean? Sine of theta is opposite the negative square root of 65. So the sine is the opposite, which is negative square root of 55 over the hypotenuse, which is 8. Okay? Cool? Tangent of theta is the opposite, negative square root of 55 over the adjacent -3. Only thing I'm going to fix here is that negative over negative is positive. Okay? Pretty simple. Last type of example here. Okay? This time they're actually telling you the quadrant. And I just totally erased it, so that's cool. Or wrote over it. But they're telling you we're in quadrant 2. Awesome. So they're telling me this cosine equals -3/5 for theta in quadrant 2. I didn't even have to figure this out. So in quadrant 2, I'm going to draw a nice angle here. Connect it to the x-axis. Here's my theta. If the cosine is adjacent over hypotenuse, that means -3 is adjacent, hypotenuse is 5. Find my third side. Okay, 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. B squared is 16. B is plus or minus 4. Well, since this is an upward measurement, we're going to assume the positive 4. Okay? So sine of theta is then going to be opposite 4 over hypotenuse 5. Tangent of theta is going to be opposite 4 over adjacent -3. Bam. Easy. Okay? Last one, quadrant 4. Okay? Draw a nice angle in quadrant 4. Connect it back to the x-axis. Here's my theta. Sine is -5 over 13. Sine is opposite -5 over hypotenuse 13. A squared plus b squared is c squared. 25. B squared equals 169. Subtract 25. B squared is 144. So B is plus or minus 12. This is a rightward direction, so positive 12 here. So cosine is going to be the adjacent 12 over hypotenuse 13. Tangent is going to be the opposite, -5 over the hypotenuse 13. And there you have it. Okay? So your assignment for tomorrow, there on your syllabus you'll see that 4.4 has 2 parts. You are going to do just part 1 for tomorrow. Okay? Now, also due tomorrow are your assignments for chapter 4.1 and chapter 4.3. So tomorrow what we are going to do, I will be back in class tomorrow, yay, is go through the homework assignments from 4.1, 4.3, and 4.4. Go over any questions you have for any of them. And then just do any more example problems for any of these sections that you have questions on. And then on Monday, you're going to have a skills check on 4.1, 4.3, and 4.4. Okay? So I cannot stress to you how important it is that you have those 3 assignments done for tomorrow so that we can get all of your questions answered tomorrow for the skills check on Monday. Okay? If you borrowed a Chromebook, go ahead and log out and get it put away. I know you're probably running really short on time here. I apologize for that. Thanks for being so attentive. Hopefully you got some good notes taken and you'll be able to get all that stuff done for tomorrow. All right? See you guys later. Have a great day.